Hey, this is Ben. I'm excited to show you what I've been up to with PiKiln. Lots of cool stuff. Let's take a look. So where I kind of left things off with PiKiln was this. I was working mostly on the front end. And I didn't really have any of the sensors hooked up, but now I do. So this is actually true. This is 80 degrees inside of where the PiKiln is. I've got a little photo that I took of the setup that I have on my desk over here. So this is kind of the setup. It's a little messy right now, and I've been playing around with how I want to wire this up and what sort of sensors and just how to get the data that I need. So one of the things that I did on this project was I built a custom circuit board, and all this is really just a little adapter board that makes it easy to just plug in different modules. So this is an analog to digital converter, which is hooked up to this guy right here, which is a non-invasive current sensor. I had to do a little bit of a few edits to the circuit board. I haven't ordered a new one just yet. I want to make sure that I get all the kinks worked out first. So I had to hook up a breadboard and do all this mess over here in order to get the analog signal of how much current is flowing through the wire into the relays into this mini little test kiln that I made. So this is just, let me show you the inside of it. So this is just like a little coil of wire, cantho wire, and a little temperature probe, and it's inside of a fire brick that I made, and I just put a little lid on top of it. And so that's what I've kind of been using as my little real world test kiln. And I've got a small, what are they called? Transformer right here that steps it down to 12 volts. So it's a little bit easier to work with. On an actual kiln, you wouldn't want to step it down to 12 volts. It's just not enough power. Anyway, so in addition to the current sensor and the relay and the analog to digital converter, we've got the temperature module. So that's hooked up to the probe over here. And that's pretty much it. And the relays are being driven through the GPIO pins on the Raspberry Pi. I have a second iteration of the circuit board more or less built. This is what it looks like. So one of the things that these non-invasive current sensors have is it's actually like a headphone jack. But what I ended up doing was on this one was I cut that headphone jack off and just took the wires and used the wires directly in a little screw terminal. But on the actual one, you'll be able to just plug in the current sensor and not have to make any modifications to it. I'm also including a little spot where you could solder in a screw terminal and do it that way too if you really wanted. But I'm trying to make it as easy as I can. So I still have the same analog to digital converter pins right here, and same thing for the temperature sensor. And then down here I made it a little bit nicer looking. So I have two auxiliary input outputs, and I've got 3.3 volts and ground on either side, and I've just got two pins broken out. I don't really have a specific use for them yet. I might do some stuff later with adding like a external fan to the kiln to add a little bit of circulation. So I'm just trying to future-proof things so I don't have to add that later. So then this part down here, this is kind of the main thing. This is for the relays. And in this particular scenario, I'm using a mechanical relay, and I'm using both of them. So I'm switching both the hot and neutral side at the same time. And what that does is it does a couple of things. One, it completely isolates the heating element from the the mains power supply. And 2, it allows me so that if one of the relays fails, I can detect that failure and notify you to say like, hey, you need to replace one of your relays. So I'm building the system in a way that 1 is super safe, 2, it can just use a off-the-shelf mechanical relay, or 3, let's see here. So it's also set up in a way, so there's 5 pins here. For the mechanical relay, you would just ignore this bottom ground pin. But if you were doing a solid state relay, you would use this extra ground and you wouldn't use this 5 volts. So I did some testing and the 3.3 volts that the Raspberry Pi can put out is enough to drive a solid state relay. It's fine. I read online that like the Raspberry Pi doesn't have enough strength to be able to pull the pins up and down to the right level, but I did some testing and it seems to be working fine. I don't know what to say. I could add some additional stuff to it, but I'm just going to keep testing without it and just see how long it goes for. And it seems like it should be fine. A solid state relay, all it is a LED that's inside of there, and that LED is it's electrically isolated. It has a optocoupler inside there. So as long as it can light up the LED bright enough, then it makes a connection for power to flow through. So 3.3 volts is plenty of power for an LED. So we'll see how it goes. Some people online seem skeptical about it, but it's been working. So we'll see how it goes. In addition to all that stuff, I have some additional pins up here that can be used for kind of hacking or modding, this sort of thing. I find that really useful and handy if you're doing custom work, and it definitely saved my butt when I made a few mistakes on this first iteration. So that's kind of the hardware side. We'll look at the software again. Now the software is like actually talking to the hardware, which is really exciting, and everything's working. The only thing that isn't working at this point is the cost estimation. So right now it's just saying like cost $355, and that's actually not true. But I can run this. So this is a short schedule that I did. It's going to say, okay, ramp up to 78 degrees, hold it for a minute, and then go to 80 degrees and hold that for a minute. And we're just going to click start. Yep, start firing schedule. And so it's going to go through this. Right now it's already at 79 degrees. So, it's going to try and decrease in temperature, but it probably won't. It's a very weak heating element, and it takes a while for it to get up to temperature, but it's been fine for testing at my desk. So you can see the progress is going by. It tells you how much time is remaining. One of the things that I'm using to control this, let me see if I can pull up this. So it's going to say I've got like a duty cycle of 4 seconds, and I'm using the simple PID Python library to control it. It's pretty cool. It's just a nice way to, really accurately hit a temperature. This is not going to be very accurate right now just because it's so few degrees that I'm increasing or decreasing. And like I said, the heating elements are really weak. So I'm probably not going to hit all of these temperatures. And we'll look at the logging and you'll be able to see that. All right, it's complete. So it tells you how long it took. I actually have my email hooked up to this now, so I should have gotten an email. But let's just look at some of the other things. The firing schedules, still it's pretty much exactly the same as how you saw it before. You can go in and edit the temperature. So make that like 90, save. We could add stages. The estimated time is now accurate. Right now it's only updating when you save or when you load the schedule. But right now what I'm doing is I'm going back through and I'm updating the entire front end to use Vue, which is a really awesome JavaScript framework that makes everything super reactive and updates like on the fly. And it's definitely going to simplify some of the code that I have. I did a lot of stuff with jQuery on this current version to make it really reactive, but my code is crazy. It's huge. It's huge. It's way bigger than it needs to be. So using Vue, it's going to simplify the code. It's also going to make the interface a lot more responsive. So you can switch between different schedules. You can duplicate them. You can export them. One thing that I changed from last time is now when you click the export button, it just automatically saves it, and it saves it with the name of the schedule. You can import in schedules. So there it is. So I just imported it in. So now I should have 2. Yep. If we go to logging, we'll see the last fire. So like I said, the firing that I just did was like 2 minutes long, and my kiln is not very responsive in terms of getting up to temperature or dropping to temperature. So the dotted blue line is what the schedule said to do, and the red line is what it actually was. I still have to hook up this part. This is just statistics about the kiln. I'm working on that. Settings. So this is, I just hooked up to Vue, and I got to clean this up a little bit. So this is updating on the fly, and it's really nice because this is all just being loaded in through one JSON file. So you can switch between Fahrenheit and Celsius. You can set the max temp. You can apply a offset to the thermocouple. You can put in your kiln voltage and electricity cost. And this is new. I updated the email notification. Before, I was relying on people to create their own custom Gmail account specifically to hook up to this system. But the more I was thinking about it, the more I thought like, that's kind of a pain in the ass to do. And then there's like a bunch of custom settings that you have to do in Gmail in order for it to work with this. And then I was thinking, well, maybe like I can allow people to hook up like just a SMTP server to it and like make it not just specifically Gmail. But then I just thought about it some more, and like, so what I decided to do was just have it so that you put in your email address, and I have like a Lambda function hooked up to API Gateway on Amazon, and it's using Amazon SES, which is simple email something. You can send emails to people for ridiculously cheap, and it's free until you hit like 65,000 emails a month. So I'm keeping that portion of this project closed sourced, but everything else is going to be open source, just because I don't want people using my email server for spam and that sort of thing. So I'm trying to keep that part a little bit more secure, but it works great. I should have gotten an email firing complete, short firing complete. So short was the name of the schedule. Tells me the duration, tells me the cost. In the title of the email, it has when it was completed. This is one from earlier. I was playing around. So this is the self-check error. So this is when the current sensor is either detecting current when there shouldn't be current flowing through the heating element, or not detecting current when there should be current. So it'll throw an error. It will stop the firing schedule. and it'll send you an email to tell you to go and check out your kiln and make sure it's okay. And then I'm working on the fan blower thing. So that's the aux input. It's not quite implemented yet. So you can go in and change these settings. So like if I want it to be 2000 degrees, shut off, save, it has, you know, the information gets saved to the server. So that's pretty much it. In terms of the actual software, I'm really excited about it. Still need to get the cost estimation working, and I need to clean up the front end a little bit. But it's at a point where this could be released in beta. You could actually use this. Be careful. I don't like it's still very much in the beta phase, and like I've only tested it out on a kiln this big on the size like at my desk. So be very cautious when you're playing around with this project. Another thing that I'm going to be doing is I'm going to order. Once I feel comfortable with this circuit board, I'm going to order more of them, get some sent over from China. I've had some fabricated in the past before from a company over there. Right now I'm using OSH Park, which is really great for like prototyping, but I'd like to get a bunch of little kits ready so that, or even potentially just like solder a handful of them together and maybe sell some of these at cost, just so that people can jump into this. Like I said, I want to make this as easy as possible for people. So and I'm going to be including the EagleCAD design files in with the repository soon. I hope you guys are as excited about this project as I am. It still has a little bit of ways to go, but you can see the light at the end of the tunnel. It's almost here, and I'm just so excited to breathe new life into the electric kilns that I have, and I hope that this is beneficial for you as well. I'm still actively working on this project, and I would love feedback from people. I welcome people to collaborate with me on this. My code isn't always the best, and maybe people can think of new features. There's lots of things that I'd love to do with this, but I need your help as well. If this is something that you're interested in, I'll have a link in the description, and you can sign up for like a pre-beta access to it, and I'll help you get set up with it. If you guys like this project, please comment, rate, subscribe, tell me some features that you'd like. I would love to get your feedback. More to come. Excited. Can't wait to see where this thing ends up.